Okay, good morning. So I want to just quickly explain what we're thinking Cinder side, and then Lang can take over and we can address the questions that are on the Etherpad and then anything else that comes up. So from our from our point of view, we're still interested in this. We're still looking at using OpenCast to do the caching. The main reason for that is that it doesn't require any kind of special formatting or anything for the volumes. So whether you attach a volume to a hypervisor that's got the cache or not, you can still use it and it's not a problem. So we're going to do this by the cacheable volumes will have something in the volume extra specs to indicate that they are cacheable. So the operator would define particular volume types for this. And we have to restrict what can be cached because so for instance, like the Ceph backend attaches in a different way, so you wouldn't be able to use it. And for multi-attach, we don't want multi-attached volumes being cached because data could get out of date. So we decided we want the end user to decide whether to use the cache or not, because presumably the hypervisors with the cache are going to be more expensive. And there may be asymmetric use cases where you want to like write stuff really fast, but when you analyze it, you got more time, so you do it on a cheaper VM or something. But anyway, so that's the basic idea. So what we were thinking was that the operator would define a flavor that had the cache with it, and then the end user would select whether they want to use it or not. So they would create a cacheable volume type, and then they would indicate that they want to actually use the cache by requesting the flavor that has the cache in it. And then if there wasn't enough space or whatever, you get the same kind of error you currently get from Nova when you're trying to boot to a flavor that's full. So we're figuring that people should be able to handle that kind of situation, right? And then if they want to, they can either wait. Well, anyway, it doesn't matter. Okay, great. So then that's the basic idea we were thinking. So we're pushing a lot of this to, it won't be quite so automatic. So we're thinking volumes will be cacheable, but whether they're cached or not, it's going to be an end user choice. And it seems like the easiest way to do that, there have been some discussions about how to do scheduling and stuff for these, and whether under what circumstances it would fail. We figure if the operator makes it a flavor, then it's a clear choice, and it either gets satisfied or not. So then moving along. Okay, so the main question that came up that sort of halted us with approving the spec, well, you can see there are a bunch of questions, but the main one was was Sean's comment on the mailing list that this was unlikely to get approved because there's a move to have every volume attached by QEMU directly, and that would bypass this type of cache that we've got in mind. So what we wanted to do was just see whether, right, what's your time frame for that, and whether it's something we need to worry about now, and also, right, how likely this spec would be to be approved. Right, because we don't want to get some work done on our side that's not going to happen, and then I'm sure you don't want to be doing work on your side that you don't want to do. So anyway, so that I will shut up now because everybody else can talk.
Okay. So I ping Sean Mooney on IRC to join, but I don't think Sean will join.
Okay.
And that point though, if you'd like, so Sean is right that eventually, potentially, we would like to connect everything up through QEMU. It's been a long-term goal, but in the near to medium-term future, that isn't likely to happen, just because the implementation of things like iSCSI and the fiber channel stuff, etc., within QEMU is a bit naive. It's not as robust as connecting up on the host with OSBrick. So into the kind of context of this spec, I don't see that as a blocker, to be honest. It potentially makes the native LUKS decryption thing a little bit harder, but there are potentially ways around that. It's an optional thing that we do at the moment on the Nova side, so natively decrypting flux volumes, or the RBD volumes directly. But yeah, with all the other block device based volumes, there's still a host block device. So even though we're natively decrypting within QEMU, there's still a block device that you could cache on that host. So yeah, I don't see that as a blocker, to be honest, for this.
Okay.
Yeah, I agree.
Okay. Great. Now somebody put some comments about encryption in here. Right. Well, ensure caching doesn't impact that. The Cinder spec's been updated so that the order stuff's attached is going to be, I think, more acceptable. Is that right, Eric? For encrypted cache volumes.
Yeah, I think the Cinder spec now says, and Nova spec as well says that the cache will only contain the encrypted data, not the decrypted data. So that's okay.
Okay, so that's good.
Yeah,
okay,
that's cool.
All right. So then, right. So a couple of things that came up, and then if you think of other things, please add them to the Etherpad. So one question that came up was use with multi-attach. So no, and the way we're going to stop that is Cinder's just not going to allow the definition of a volume type that's both cacheable and multi-attach type. So that should handle that. And then with RBD, we can't use it. So Cinder, again, will not allow a volume type to have both RBD as the backend and be cacheable. And then you can't use it with NFS type backends. So I had a question. I think Cinder can prevent this in the volume type creation, just like with RBD. So I think we're okay there. Eric, you're muted if you were talking. Okay, and then with multipath, right, we don't want to allow that because you don't want to have a path through the cache and a path around it. So I wasn't clear myself how we were going to prevent that. Do we have an easy way to stop that? I haven't read your latest update, so if you've addressed this, I apologize. This is line 38 in the Etherpad. All right, I'll be quiet. Eric is trying to unmute his phone line. All right, so I'll hold off while
Oh, there we go.
Okay, great.
You got to hit *4. I couldn't find how to do it.
Okay.
Yeah, I think the spec has the right stuff in it now, as far as encryption.
Okay, great. All right, so with the multipath, is multipath like a associated with the volume type, just like multi-attach, or is it specified a different way?
No, it's just done by the backend.
Okay.
And how Nova is configured to use it.
Okay. So do we have a clear way to prevent the cache being used in that case, or do we need to keep this as an open question?
I think Nova just has to enforce that and how it attaches things.
Okay.
So Eric, the problem there is that even if we're caching the multipath device directly, if the paths switch over, things could get out of sync behind the scenes.
Well, I'm not sure. The Cinder spec did not spell out in any way how this would interact with multipath.
Right.
So I'm not really sure if there's a reason to turn that on and expect it to work right, or
if you did it against the multipath device itself, then it should. But I get the point. If you put the cache against one of the paths and the paths flip over, things will break. That's given. That's why there's a multipath device that unifies everything. But yeah, there must be material around this anyway, because I think you can layer DM cache on top of a DM multipath device anyway. So there's probably recommendations around this. So that probably needs a bit of review. I haven't actually commented on the Cinder spec in a while, so I can go take a look at that and suggest that a bit more research is done there.
Okay, great. Okay, and then the NVMeOF driver. Okay, so it should be cacheable if it's mounted as a block device. That'll be okay. One thing I wasn't sure about, do we have any restrictions on retyping the cacheable volume?
Well, there's all the stuff about migration, but I guess we can get into that part later.
Okay.
As far as other retyping, not too sure.
Okay, and then
one thing that might be relevant there is this whole scheme is kind of designed with the assumption that a deployment is only going to use like the OpenCast driver or not cache things.
right.
If in the future we're going to support other cache methods, which I think is the theory, there's a lot of questions around how types actually work at that point, because the volume types, as described in the spec, just say cacheable, yes, no, and then if we end up with different ways to cache things, we have to figure out how you determine which one you're using and if that needs to also be in the type. So there may be interesting questions around retype later, but I think we may want to figure out if the way that we're doing this in the volume type specs right now is actually going to suit what we may need to do later if we have more tools in this.
You could change it from a bool, which is cacheable yes, no, to cacheable, and then list the backends that would be supported. So you could have cacheable and then OpenCAS, and that would be the only thing that would be supported initially. And then you could add in other types.
Yeah, but you also have the same concern around.
Sorry, Eric, go ahead.
So you also run into the same thing if OpenCast supports 3 different methodologies for how the cache is operating, as far as write through, write back, whatever. You run into the same thing there if you want to have different ways to do the caching in the same deployment, even if you're only using OpenCast.
Yeah, although that feels orthogonal, right? Write back, write through, write around should be transferable to other caching types, so it shouldn't be in the same key. It should be a separate thing to say how it's cached, ideally.
That's a good point. I forgot to put this on here. I was pushing that this would be kind of a Nova thing. So if you wanted different cache modes, then that would be specified as part of the flavor. So for instance, if somebody didn't care about a safe mode, then the flavor could say, here's this is a you can land a VM here, it'll be cacheable, and it's going to be, super fast writes or whatever, or reads, depending, just one of the unsafe modes.
Yeah, so we already have a disk cache operation for QEMU's internal memory caching. Often the Nova config, so you could potentially extend that for cacheable volumes. At the moment, you can basically specify the disk cache mode for file, network, and local block devices. But we might be able to add volume there, and then you could choose the option.
Okay. So that could be done. So I was thinking if you push it to the Nova side because cache mode seems to be a property of the actual, where you land of the host rather than the volume.
So if it was on the Cinder side, we would need to start modeling this as a trait and then use it as part of the placement decision of where we land the host.
Okay. So does pushing it to Nova seem, so it could be doable either way. It seems like the infrastructure's in place. It would take more, well, it's going to take some on either side, right?
Well, one thing that as soon as you want to differentiate like a cache mode per volume, and you have a server with more than one volume with different cache modes, then it's more natural to define the cache mode on the volume side, not on the flavor side, because we have one flavor and maybe two volumes in the same boot request.
Oh, I see. Right.
Is this something that's in scope for the initial version?
I don't think so. So how I read the Nova spec and the Cinder spec is that we want to have one single bit of information in the flavor telling Nova to cache the volumes, all the volumes of the request, or don't cache the volumes of the request. And I think that's a good first step. But as we're now talking through other parameters of this caching, like the cache mode, or if you have different drivers, maybe two different drivers on the same host, and selecting from those, selecting from the cache mode is more natural to be per volume, not per boot request.
Yeah, and that's essentially something that we already do with encrypted volumes. So you can have different providers per volume attached to the same instance. So that might be a way of implementing this with hash providers or something in the US brick tree that then map to individual traits and capabilities on the Nova side eventually. But yeah, for now, the initial approach seems good enough.
Okay. All right, I think we're at line 48 maybe about resizing. So it seems like that's going to be an okay operation because you detach the volume, resize it, and then when you reattach, everything's set. So the detach is going to flush the cache, things will be written, and then after you do your thing and reattach it, you'll have a fresh cache set up for that size volume. Okay, and then as far as extending a volume, might have to not be supported.
I think attached extension or resized should probably work. If we're using write back cache, as long as everything's in sync everywhere, that should be fine. QEMU, well, for the libvirt driver at least, QEMU will ensure everything's up to date within the instance at the end of the operation. So yeah, I'd have to test it, I guess, just to prove it, but I can't think of anything that would stop that from working at the moment.
Okay.
Well, I think we're assuming there that we don't have to poke the cache layer and tell it that the volume got bigger, right?
Right. Yeah, I wouldn't think you would need to do that. But in OpenCAS, do you have to tell it that the volume is this big, so reserve this much cache from it or something?
That's a question for Liang. All right, we'll make sure we get this addressed.
But even if we did have to do that, that's potentially something we could wire up into that particular flow and call OSBrick to do the poking for us. We already have specific calls that we need to make anyway to OSBrick to extend the volume.
Right. Okay.
while it's attached, so you could just wire it up in there if also cached, poke OpenCAS.
Okay. And I think with the encrypted volumes, we're thinking that the data flow is looking good now. So we're okay there. Now this does impact live migration. So our plan was for phase one, only allow safe cache modes. So then there should be no problem because the data's all in the back end that's in the cache. And then what was I thinking when I wrote this? So Nova will give Brick a list of available cache instances, and then Brick uses the cache admin tool to find out what cache mode is set on the instances. So it can detect whether it's a safe mode or not. Problem we've got though is operators configure the cache completely independently of Cinder and Brick. So it's possible that you could change the cache mode after Brick had already attached and said, hey, this is safe, and then make it unsafe. So that's unsupported. We were thinking we would just document, don't do that, which seems like a reasonable thing to not do.
Yeah. Could we also do a check in init host when the compute agent starts up to get it to ask all of the cache modes via OSBrick whether or not they're safe, and then bail out if it's configured to be unsafe?
Yeah, why not? Or yeah.
Okay, so all right, good. Somebody. Okay, and then it looked like, so the phase two would not be part of this, but we're just thinking ahead. We would allow unsafe modes because they're probably applications that would really, like to have the speed safety trade-off. But we would have to make sure we could flush for snapshots, backups, consistency groups, and live migration. And that we currently don't have.
So there's kind of two categories here. I mean,
okay.
Consistency groups and live migration, will fail to function the way they're supposed to function. Snapshots and backups kind of are different because they'll still work. You just end up with, if you do a snapshot on a Cinder backend, you don't really know what data is in there because the point in time, guarantee of the snapshot no longer exists since a bunch of data could be in the cache. So the snapshot and the backup one is because of the implication for snapshots. The snapshot case, we could kind of go either way on. I mean, we could just document snapshots, aren't going to be capturing all of the data right when you take them. They might capture slightly stale data, but they'll still be consistent. Or we can opt for cache flush. I don't know. I'm kind of not sure.
Does the QEMU guest agent help us here? So for when we're using RBD backend, we can enable the QEMU guest agent and have it quiesce the guest so that no writing is happening when inside the guest. So in the unsafe case for snapshot release, could we rely on the same thing?
Well, I think if you're using a write back. Yeah, I don't know. I think if you're using a write-back cache, you still have to do an actual cache flush in OpenCAS.
Yeah, my point was you'd have to QS the cache essentially as well to ensure that everything actually made it to Cinder, right?
Okay, so when we do the current quiesce of the guest via the QEMU guest agent, could we in parallel then do a sync of the cache and do, force that flush or quiesce?
Yeah, potentially. I'm not sure how that would work at the moment. If we'd be able to tell QEMU to come back to us and then do that flush, and then go back to QEMU and say unfreeze things. But yeah, assuming we can do that, that should be possible.
Do we actually know if OpenCast has a way for us to request the flush? I thought one of the concerns was that we didn't actually know if we could even do that right now.
Well, I just sort of assumed that it was like a figured it had to, but that's a good point. We need to. Yeah, I mean, my point in bringing these up, even though we're not going to implement them now, is that my feeling is really the cases that people are going to want to use are these unsafe modes because they're the fastest, and that's the whole point. And if it's going to be difficult.
Well, actually, on that,
okay,
will it be the fastest? Because right back, we're going to tell the guest OS that we have committed the second it's committed to the cache, right? It doesn't need to be committed all the way back to the backing store. So it should, in theory, perform close, if not the same as unsafe. Because unsafe, the only difference is we ignore explicit flushes from the guest OS.
We were thinking of the unsafe being the write isn't acknowledged until it's reported from the back end. So you don't get the quick.
That would be write isn't report from the back end. Yeah. So write through means that the cache has got the write and it's been committed to the back end. Write back means it's been committed to the cache only, but not committed to the back end. So how does that change from your unsafe?
Right. So I'm thinking the write back would be unsafe because if we got detached, we'd have data in the cache that's not been written yet to the back end.
It's on the back end, but it is persisted to the local disk so that it could be written back at a later date, right?
I'm not so sure.
Yeah, but I think it's not clear that that's sufficient for the live migration case. Because in live migration, if you're going to do
yeah, for live migration, we would have to force a flush from the cache to the back end. Otherwise, we would have to copy the cache data to the other host.
Right. Okay, and then we're almost at time. If you've got a couple of minutes, let's just. So a question about how we're tracking the quantifiable cache resource on the Nova side. It's just going to be a host capability.
Yeah, so I think as a first step, we just track that this host is capable of caching volumes or not. We're not tracking it that how big the cache is or what type of cache mode we have configured there.
Okay.
Yeah, that's cool. There was just discussion earlier about flavors and there being some kind of amount of cache attributed to a flavor, but I didn't think that was in the first iteration, so I just wanted to call it out. Yeah, hopefully, eventually, that's planned, right? Because you could have a case, and I think Dan Smith probably brought this up early on with spec, but you could have a case where people slam a particular host with cached volumes and then slam the cache, and suddenly the node is dead.
Okay.
If there will be need later to track the cache size, then this will be more like a resource emplacement, and then we somehow need to figure out how the shared cache works. So
we could do what we did for guaranteed bandwidth, right? So we declare how much cache is available, and then we just track the minimum. We don't need to actually enforce it at the cache layer. We just make sure we don't oversubscribe.
Yes, so we can do that, but then that leads to different things. Like at that point, I think the cache size, the requested cache size is per volume, not per flavor. And then this information that how much cache a volume it needs should come from Cinder. Like the minimum bandwidth request comes from Neutron.
Yeah, I think that makes sense.
Work.
It also means that if we have a special resource class for this as well, we can tie into unified limits for quota on how much cache it can use in a fairly clean way.
Yep.
So at a more basic level, you guys may have just covered this and I missed it, but I don't think the Cinder spec talked a whole lot about capacity of the cache and what happens if you have 1 terabyte of space to cache in on the compute node and you fill it up, and that kind of thing. I'm not sure the spec covered any of that kind of behavior.
I think that's going to be backend specific, right? Because like if you're using something like bcache, it will manage expiring data out of the cache and propagating it back. So I think that's likely going to be dependent on whether you're using OpenCAS or what tool you're using, how that's actually managed.
Yeah.
Like if it's DM cache, you manually allocate a specific cache volume for each individual backing device. So it gets a dedicated region and you can change it individually. But for something like bcache and OpenCAS, I think it's set on the cache pool itself rather than per volume that's being cached. So I'm not sure we need to specify that here. We would certainly need to understand it though if we were going to allocate X amount of cache to an instance or schedule based on that.
Yeah. Okay. All right. We're at time, so I really appreciate everybody showing up. So it sounds to me, just to quickly summarize, this seems like we could go ahead with it. Right. There's some questions we need to address, but it's not like out of the question that it could be done UV timeframe. Well, probably more V. But it's okay. But it's worth going through. It's worth continuing with this. Seems to be the thing. Okay.
Yeah,
right. Thanks. Well, if you have any second thoughts, please add them to the Etherpad. That'll be available, and then we'll be updating. Liang's already updated the Cinder spec. There's a new one out right now, but he'll update with addressing these questions, and then we can continue. But I really appreciate everybody showing up. So thanks for helping us get this moving along. So you can stick around if you want, but otherwise enjoy your day or evening or whatever you got coming up.
Thank you.
Hey, bye.
Cheers, bye.
Thanks.
See you.
Thank you. Bye.
Right, I'm going to turn off the recording.